Night settles over rooftops and deserts, and with it the tender hush that makes distant stars seem closer than the walls of any room. He watches the firmament open, slow as a curtain rising, and feels a quiet recognition begin. The human pulse keeps time with a larger rhythm here, a rhythm older than language, older than grief, older than names. This is not the frightened darkness of the unknown. This is a darkness that cradles. Somewhere beyond sight, hydrogen learns how to glow, gravity learns how to gather, and light learns how to remember the path it has taken. Beauty arrives in the simplest way possible. It arrives as a feeling that the world fits. He listens to the faint surf of night air and senses that the universe holds a soft order, not the rigid order of a clock, but the living order of a tide. Galaxies rotate with the patience of seasons. Clusters drift like archipelagos that forgot they were once part of a single shore. The sky does not argue its case, it breathes it. Even the darkness carries a texture, the way velvet carries both depth and warmth. The mind rests here because the cosmos seems to arrange itself into patterns that invite rest. He thinks of first principles the way an artisan thinks of tools, simple forms that carve everything else. Space is not a backdrop to events. It is the fabric that gives events their shape. Time is not a sequence of beads on a string. It is the string that gives beads their relation. Mass is a kind of permission for space to curve, and curvature is a kind of invitation for matter to move. Nothing in this feels forced. The ideas fall into place as dew finds leaves, as snow finds branches, as a lullaby finds the breath that sings it. He remembers that light travels at one constant pace, an unwavering tempo set by the nature of reality itself. That single limit governs storms around black holes and the glow of fireflies in summer. It keeps promises across billions of years, ferrying images from faraway eras with a patience no messenger on Earth could sustain. The constancy is not cold, it is generous. It allows the universe to be readable. It allows distance to mean something, and history to exist at all. The mind relaxes inside that reliability, like a boat that trusts the steadiness of a river. He notices the effortless arithmetic of gravity. Two bodies call to each other, and the call weakens with distance in a way that feels as natural as shadows growing thin at noon. Orbits emerge as if they were the native dance of mass, circles and ellipses woven from the same thread that guides a falling leaf. There is no strain in any of this, no noise of gears. The cosmos prefers curves to corners, continuity to fracture. Even catastrophe, when stars collapse or collide, resolves into new forms of clarity. Shock becomes architecture. Ruin becomes pattern. What begins as heat ends as shape. He considers that the smallest things carry their own soft wonder. An atom is mostly empty, yet in that spaciousness, it holds the rules that let chemistry sing. Electrons do not turn like moons. They hover in probability, and even that strangeness hums with a serene logic. There is room for surprise, yet the surprises are fluent in a grammar that never collapses. The microscopic and the cosmic mirror each other in this respect. One speaks quietly, the other speaks in cathedral thunder, but both speak the same language of relation, balance, and return. He reflects on the softness of cosmic light. Even when violent processes produce it, once released it becomes gentle, spreading across darkness with a patience that would seem divine if it were not so natural. It arrives at the retina and becomes an electrical whisper, then a thought, then a memory. Stars that died before language now lend calm to rooms where someone cannot sleep. This is a gift wrapped in distances. The universe keeps sending it, and the human mind keeps unwrapping it, night after night, as if their companionship were inevitable. He lets his attention settle on silence itself. In the silence, the universe is not empty, it is poised. So much happens within it that stillness becomes a medium rather than an absence. Between galaxies, particles drift in tenuous seas. Between heartbeats, feelings rearrange themselves. The same quiet that lets sound be heard, lets meaning be found. He senses a kinship between the pause in a symphony and the intergalactic void. Both hold potential, both lend weight to what frames them. Beauty is not forced to be loud. It can be the gentle pressure of almost nothing. He finds comfort in the modesty of the elements. Hydrogen and helium are simple, yet from their simplicity arise stars, planets, oceans, and the long stories of living cells. The ladder from simplicity to richness feels stable, as if reality likes to ascend with steady rungs. The universe resists clutter. It chooses a few ingredients, a few rules, and lets time do the rest. The result is not chaos. The result is generosity. Structures repeat at different scales, not because they are dull, but because repetition is a way of teaching. The cosmos teaches through echoes. He recognizes that beauty, here, is not a decoration added to truth. It is a sign that truth and coherence have met. The mind calls a thing beautiful when parts fit together with ease, when nothing can be removed without loss, when the path from premise to consequence feels like a glide. The heavens offer that glide. They give reasons that feel like rivers, and outcomes that feel like the sea. Wonder is not an interruption to understanding. Wonder is the beginning of understanding. It relaxes the guard of restlessness and invites attention to stay. He lets the thought rise that existence might be kind, not in a sentimental way, but in the way a well-made bridge is kind to those who cross. The cosmos supports meaning simply by being legible. It allows questions to find footing, and curiosity to plant roots. There is hardship, yes. There is entropy, yes. There are distances so large whole civilizations could vanish within them and leave no echo. Yet even these truths fall into a poetry of relation. The hard parts are written in the same hand as the gentle parts. The script is one, and it is graceful. He closes his eyes and imagines the hush between stars as a cool field where thought can lie down. In that field, he places the simplest facts like smooth stones. Light travels with one speed. Gravity curves space. Matter and energy converse in a single tongue. These stones are enough to build a hearth. Around that hearth, he feels less alone. He does not need every answer. He needs the sense that answers are possible, that the universe is not hostile to understanding. The sky, even in its vastness, offers that tender assurance. He breathes, and with each breath the cosmos seems to breathe with him. Expansion is not a rush. It is a slow exhalation that will take ages to complete. Stars are not in a hurry to burn. They pace themselves across epochs. The scales are colossal, but the attitude is gentle. If there is a lullaby here, it is written in patience. Patience of light, patience of gravity, patience of change. He allows that patience to enter him. The night does not demand, it invites. He answers that invitation by listening, and in listening he finds rest. In the quiet hum of a century turning toward reason, a few minds began to suspect that beauty itself might be a compass, not a metaphorical one, but a real guide within the landscape of natural law. The world had just begun to name its equations, to write the grammar of symmetry and conservation, and with each discovery came a new kind of astonishment. The more balanced an equation was, the more truth it seemed to contain. The story began, softly, with a young mathematician who saw harmony not as decoration but as destiny. Emmy Noether worked in an age when her voice was almost excluded from the rooms where physics was being reborn. Yet she entered those rooms through the strength of clarity. Her theorem, born in the early 20th century, drew a luminous line between beauty and law. It whispered that whenever nature exhibits symmetry, whenever a process looks the same through shifts of time, space, or angle, a conservation principle must arise. Time symmetry gives conservation of energy. Spatial symmetry gives conservation of momentum. Order, it seemed, was not a preference but a requirement, and beauty was not adornment but foundation. Einstein read her work and recognized its gravity. His own equations already leaned toward elegance, a single, curved geometry replacing the clutter of invisible forces. When Noether revealed that symmetry gives rise to conservation, she handed him the missing mirror in which his theory could admire itself. The universe was not just functional, it was self-consistent in a way that pleased both the mathematician and the poet. From then on, the idea of symmetry would echo through every field, turning the search for beauty into a legitimate scientific pursuit. Symmetry soon became a quiet mantra in laboratories and lecture halls. In the patterns of crystal lattices, in the balanced spins of particles, in the mirrored halves of equations, the same song was heard. If the world is beautiful, it must be conserved. If it is conserved, it must be symmetrical. The physicist's task was no longer to tame chaos, but to listen for harmony. Even in randomness, subtle symmetries waited to be noticed, rotations that left probability unchanged, transformations that shifted nothing essential. The universe behaved as if it loved to disguise perfection under layers of apparent mess. To some, this was simply mathematics doing its duty. To others, it felt like revelation. A single rule could birth 1,000 consequences. The conservation of energy became not just a fact of measurement, but a kind of cosmic promise. Every flicker of heat, every falling apple, every decaying star obeyed it without exception. It was as though the universe refused to waste itself, guarding its balance with the precision of a dancer holding a pose. Even entropy, that slow drift toward disorder, existed within boundaries that symmetry allowed. The language of symmetry began to evolve. Groups and transformations became the new alphabets of physics. Rotation, reflection, translation, each was a gesture of balance. When these gestures combined, they formed mathematical families that could predict new particles, unseen yet necessary. The invisible scaffolding of matter began to emerge, traced not through experiments alone, but through the geometry of possibility. Scientists found that by demanding beauty, they could anticipate existence. Entire species of particles, neutrinos, quarks, bosons, were foretold by the insistence that the universe's equations remain fair and balanced. Symmetry, however, was never rigid. It allowed imperfection in just the right places. When symmetry broke, diversity appeared. The difference between light and matter, between force and substance, between stable and fleeting, arose from small asymmetries that enriched the cosmic pattern. A perfectly symmetrical universe would be sterile, a slightly broken one could evolve. Beauty, then, was not mere perfection. It was the tension between balance and fracture, between stillness and growth. This new understanding reshaped how scientists dreamed. The laboratory became a kind of chapel where the sacred geometry of nature revealed itself through the patient alignment of data. Physicists began to see equations as living objects, capable of emotion, because they responded to the simplest rule: be symmetrical and you will endure. From that quiet directive, galaxies spun, electrons danced, and light itself refused to age. The notion that beauty could lead to truth was unsettling at first. Science was supposed to be impartial, grounded in observation, not seduced by aesthetics. Yet again and again, the most elegant formulations proved correct. Newton's laws, Maxwell's equations, Einstein's field relations all carried a refinement that seemed to hint at inevitability. Their lines were few, their symmetry deep, their results universal. It was as though nature herself preferred simplicity that glowed. And so the compass, called symmetry, continued to turn, guiding explorers toward hidden continents of understanding. It pointed beyond the immediate world, toward realms where forces merged and particles shared ancestry. To follow it was to believe that the universe was not a random sprawl but a woven design, its threads arranged with taste as well as necessity. The deeper scientists looked, the more that sense grew. Beauty might not be the goal of physics, but it was the scent left by truth as it passed. In the stillness of night, when numbers rested and the hum of machinery fell away, one could almost feel the symmetry of existence breathing. Every opposite required its companion. Every action echoed its reflection. The cosmos seemed to murmur that balance was its first language, and that all the stories of matter and light were but translations of that single, elegant idea. There came a moment in science when beauty stopped being a quiet companion and became a shock. The expectation had always been that truth would be messy, that the deeper one peered into the machinery of the universe, the more tangled its gears would become. Yet the opposite kept happening. When minds reached into the heart of complexity, what came back was simplicity so refined it felt improbable. Nature was not merely consistent, it was graceful. It behaved as if elegance were a law unto itself. This realization unsettled even those who loved symmetry. Equations that could fit on a single page, even a single line, began describing entire kingdoms of reality. Maxwell's 4 concise statements unified electricity, magnetism, and light into one harmonious field, turning chaos into coherence. Einstein's slender relation between geometry and gravity redrew the map of space and time with a quiet confidence that outshone centuries of speculation. The shock lay not in the complexity of their vision, but in its lack of clutter. When simplicity predicted storms on Jupiter and the bending of starlight alike, science began to wonder why beauty was so effective. It seemed indecent, almost suspicious, that elegance could rule the universe. The human world was not elegant. Its cities were tangled, its hearts confused, its choices noisy. Yet above this chaos, the cosmos followed an austere rhythm. Energy moved with efficiency, forces balanced like verses in an ancient poem. The equations did not flinch, even when they predicted things never seen before: radio waves, gravitational bending, atomic clocks. Again and again, reality bent to match the clean handwriting of mathematics. Physicists began to speak of the unreasonable effectiveness of these patterns, though the phrase would not be coined until later. How could symbols on paper, invented in quiet rooms by limited minds, correspond so perfectly to the behavior of stars, particles, and time itself? Why should differential geometry describe the curvature of the universe? Why should a symmetry group, invented for beauty's sake, predict particles yet undiscovered? It was as if the act of seeking aesthetic balance tuned consciousness to the same frequency as creation. Some resisted the implication. Perhaps it was coincidence. Perhaps only the successful equations were remembered, while countless ugly failures were forgotten. Yet the record of success kept expanding. When Dirac sought an equation for the electron, he demanded that it be both consistent and beautiful, and from that demand emerged antimatter, a prediction so strange and precise it seemed like art creating fact. The shock was not just that the equation worked, it was that beauty itself had guided the hand that wrote it. In laboratories, new devices began to probe what equations had already foretold. Cloud chambers caught glimpses of unseen symmetries. Tracks curved and mirrored like calligraphy in vapor. The atom, once imagined as a hard sphere, turned out to be a cathedral of waveforms, its architecture composed of harmonics and probability. The deeper physicists looked, the more the universe resembled music frozen into geometry. Frequencies, nodes, and resonances replaced the image of tiny planets circling a sunday. The structure of reality was harmonic, not mechanical. The shock deepened with relativity. Space and time, thought to be separate, fused into a single continuum. Mass and energy, opposites by intuition, revealed themselves as interchangeable faces of the same essence. Gravity was no longer a pull but a curve, not a force but a whisper in geometry. The elegance of it left even Einstein uneasy. He had not meant to write poetry, yet he had written the kind that could move stars. The simplicity of his vision was disquieting because it worked too well. For those watching from the edge of philosophy, this elegance hinted at something profound. If beauty could predict truth, then perhaps beauty was not a human projection, but an intrinsic property of existence. Maybe the universe was intelligible because it was aesthetic at its core, not in color or sound, but in form and relation. The human mind, evolved to recognize pattern and proportion, might simply be recognizing itself in the mirror of reality. What looked like reason was resonance. Others found this thought troubling. If beauty was so central, then ugliness must have its place as well. The irregular, the chaotic, the broken, these, too, belong to the cosmic pattern. Supernovae tore apart the orderly dance of stars, yet, from their wreckage came the elements that would later build planets and minds. Even decay and disorder fed the grand equation. The symmetry of existence included asymmetry. Its harmony contained dissonance by design. The shock of beauty, then, was not that it excluded chaos, but that it made room for it without losing grace. It became clear that elegance did not mean ease. The universe was still fierce, still immense, still indifferent to comfort. But beneath that indifference, an intelligence without intention seemed to operate an insistence that simplicity should be enough, that efficiency was the soul of creation. Equations continued to shrink while their consequences expanded. Whole galaxies of prediction grew from lines compact enough to fit on the edge of a notebook. The most beautiful theories were not ornate. They were serene, and so the shock remained. That beauty could be real, that simplicity could be powerful, that order could hide inside turbulence. The scientist, the dreamer, and the sleepless listener alike could take solace in this. The universe, vast beyond sympathy, was not random after all. It was deliberate, in the quietest sense of the word. Beneath the noise, beneath the distance, Beneath the fear of meaninglessness, there waited an assurance shaped like a smile in mathematics, an assurance that truth and beauty were, perhaps, the same thing seen from opposite sides of infinity. The story of the universe began to reveal its first photograph, not through a telescope, but through a radio receiver. In 1965, two engineers at Bell Labs were calibrating an antenna meant to listen for satellites when they stumbled upon a whisper that would not fade. It came from every direction, steady and cold, like the breath of the universe itself. No matter where they aimed the instrument, the sound persisted, a faint, unending murmur of static. Arno Penzias and Robert Wilson thought it was interference, perhaps pigeon droppings in the dish. But when they cleaned the instrument, the whisper remained. They had tuned in to the oldest light in existence. That light, though invisible to the eyes, held the first memory of creation. It had begun as fire, the fierce radiation of a universe only a few 100,000 years old, and had stretched, cooled, and softened as space itself expanded. What once blazed as pure brilliance now arrived as microwaves, photons so weary they carried no color, only temperature. This was the cosmic microwave background, the afterglow of the beginning. It was not loud, yet its presence changed everything. For the first time, the universe had given us a self-portrait. When scientists mapped that glow, they saw something astonishing. It was nearly uniform, smooth across the sky to one part in 100,000. The entire cosmos, from one horizon to the other, shared the same ancient temperature, about 2.7 Kelvin above absolute zero. This evenness meant that the universe had once been intimate, its matter and light entwined, communicating before expansion drew them apart. Yet there were faint ripples in the smoothness, tiny fluctuations in density that would one day grow into galaxies, stars, and the delicate structures that cradle life. Out of uniform light, difference was born. Those ripples told a story older than any mythology. They showed that the young cosmos had not been chaos, but music. The fluctuations were acoustic, literal sound waves rippling through the plasma of the early universe. The cosmos had once sung. Its song lasted 380,000 years, filling space with oscillations that would later be frozen into the background radiation we now detect. In that frozen music lay the score of everything to come, where clusters would form, where voids would remain empty, how light would weave through time. The image produced by satellites like COBE, WMAP, and Planck later revealed the pattern in exquisite detail, a mottled sphere of subtle temperature shifts, blue and red patches like brushstrokes on the first canvas of being. Each color was a note, a signature of sound turned into structure. The map was not just beautiful, it was an answer to questions once thought unreachable. It confirmed that the universe had a beginning, that space had expanded, that light had cooled, and that the laws of physics had remained faithful from the first, second, until now. To stare at that map is to feel both reverence and vertigo. It is a baby picture of the cosmos, taken when atoms were still assembling, before stars, before elements, before time had rhythm. The entire visible universe, billions of galaxies, clusters, and nebulae, was compressed into a plasma barely thicker than fog, glowing with a calm that belies its future. That faint radiation still surrounds every living thing. Every breath we take, every signal that travels through the air, moves through the residue of that first light. The discovery carried a kind of moral weight. It meant that the night sky, vast and dark, is not empty but full of memory. It hums with the residue of origin. Each patch of that microwave light is a fossil of temperature, a note from when space itself was only a few 100,000 years old. The scale of time bends in the mind trying to contain it. The photons that reach our instruments tonight began their journey before the first atom cooled, before the first darkness fell. And within those photons lies information so precise it borders on poetry. From their slight variations, scientists inferred the total shape of the cosmos flat, within a fraction of a percent. They estimated its age, its density, the proportion of matter, dark matter, and dark energy. A universe that had once seemed unknowable now offered its blueprint in a whisper of radiation. The precision was humbling. From the faintest noise, a cosmic symphony could be reconstructed. Yet the beauty of the discovery was not just in the data, it was in what it implied about connectedness. Every atom in every body, every planet, Every star shares ancestry in that light. It is the one inheritance that binds all existence. To gaze into the map of the cosmic background is to see a family portrait, not of species, not of galaxies, but of reality itself learning how to breathe. The same photons that now pass through our bodies once danced among the first ions of creation. We are not beside the beginning, we are within its ongoing glow. Late at night, when the human world sleeps, that glow continues its slow, steady journey. It does not flicker, it does not age. It moves through walls, oceans, and dreams alike. The cosmic microwave background is not a relic. It is the soft heartbeat of time, reminding those who listen that creation never truly stopped. The universe is still exhaling, still carrying forward the warmth of its own birth, gentle and infinite, like the lingering heat of a star that refuses to fade. When the first maps of galaxies were drawn, the universe revealed a strange and exquisite pattern, spirals within spirals, clusters linked by faint filaments, voids vast enough to swallow entire superclusters. What seemed like randomness from afar turned out to be a structure of breathtaking order. Galaxies coiled like seashells and drifted in tendrils that resembled neural pathways, as though the cosmos were thinking in stars. It was not chaos at all. It was choreography, patient and immense. Each spiral galaxy moved with an elegance that seemed to contradict its violence. Billions of suns turned in unison, each orbiting the center as if obeying an unspoken rhythm. Arms of dust and light curled outward, forming designs that repeated across uncountable scales. The Andromeda Galaxy, the Milky Way, the pinwheels scattered across deep-field images all shared the same mathematical grace. These were not static ornaments, but living vortices of gravity. They spun, expanded, merged, and drifted, creating a visual harmony that spoke of a deep, consistent logic. Astronomers began to notice that this harmony obeyed rules that echoed those found in nature on Earth. The golden spirals seen in galaxies mirrored the curves of hurricanes and seashells. The same logarithmic patterns that guided the growth of sunflowers also shaped the cosmic whirlpools. Gravity was not chaotic, it sculpted with precision. It distributed matter with an artistry that made even destruction serve design. Supernovae tore through gas clouds, yet from those wounds came the birth of new stars, new light, new symmetry. No hand conducted this cosmic ballet, yet its rhythm never faltered. The balance between attraction and motion kept each system intact. If a star moved too slowly, gravity would pull it inward. Too fast, and it would fly away. Every orbit was a compromise, a perfect tension between freedom and restraint. That tension is what gave galaxies their form, not static perfection, but dynamic balance. The universe, it seemed, loved equilibrium in motion. The more powerful telescopes became, the more profound this balance appeared. Astronomers watched galaxies collide in slow motion, an embrace that lasted billions of years. Instead of ending in ruin, the collisions often birthed new beauty streams of stars, stretching like luminous bridges, cores merging into radiant hearts. Gravity, patient and impartial, used even chaos to paint new symmetry. Destruction was merely another brushstroke in creation's unending art. The spiral arms themselves told a story of movement and memory. They were not fixed structures, but patterns that traveled through the galactic disk like waves through water. Stars were born in those waves, lived their lives, and died as the pattern moved on. What the eye saw as permanence was, in truth, a slow ripple of renewal. The galaxy was not a frozen wheel, but a breathing entity, shedding and reclaiming light in endless rhythm. To study such order was to encounter serenity. The vastness did not intimidate, it soothed. Gravity worked with such calm authority that even its fiercest acts seemed graceful. A black hole could consume a star without noise, leaving behind a ring of light that spun with quiet dignity. Cosmic filaments stretched across hundreds of millions of light years, yet their distribution followed the same soft mathematics as soap bubbles joining at edges. Beauty persisted at every scale, as if symmetry were not imposed but inherited. When supercomputers began simulating the formation of galaxies, the results carried the same astonishment. From simple rules, gravity, expansion, and cooling emerged networks that matched the observed universe almost exactly. Out of equations, structure unfolded naturally, like frost spreading over glass. No adjustments were needed, no intervention added. Complexity arose from simplicity, and beauty arrived without invitation. The universe seemed to prefer grace as its default condition. The cosmic web, that grand architecture of filaments and voids, extended this harmony to unimaginable distances. Each filament held clusters of galaxies, bound by dark matter whose presence could only be felt through gravity's pull. Between them, vast empty regions opened like pauses in a song, spaces where light rarely traveled. Even the emptiness had purpose. It defined the structure, gave contrast to brightness, allowed form to breathe. Without the voids, the filaments would have no meaning. Silence was part of the melody. The spiral, the filament, the void, these were not random outcomes, but expressions of balance on every level. The same laws that governed the fall of an apple guided the motion of galaxies. The same curvature that bent a beam of light around the sun shaped the pathways of superclusters. The cosmos operated like a single body, its limbs stretched across eons, each movement connected to the others by invisible threads. In the night sky, those threads can almost be felt rather than seen. The faint arc of the Milky Way across darkness is a reminder that order survives scale, that motion itself can be a form of stillness. The spiral arms trace paths so old that they fold time into their curves. Every star, every dust grain, every shadow between them moves according to laws that do not falter. There is peace in that inevitability, a peace that has no beginning and no end, only rotation, symmetry, and continuation. Somewhere in that turning, the human mind finds rest. To know that the same gravity holding galaxies together also keeps the body on Earth's surface is to feel belonging. The cosmos is not distant, it is participatory. Every heartbeat follows the same mathematics as the orbits of stars. Every breath moves within the same curvature that bends the Milky Way into its luminous arc. The harmony that governs the heavens governs us too, softly, invisibly, without demand. Numbers began to take on a strange intimacy when they started to predict things no one had ever seen. The universe was becoming legible through symbols, not vague metaphors, but exact patterns written in mathematics. Before telescopes found the nebulae, before instruments captured the radio hums of space, the equations were already whispering what waited beyond the horizon. It was as if the cosmos had left clues in the margins of its own story, waiting for those who could read its quiet language. The power of these numbers was not in their complexity, but in their restraint. From Newton's law of gravitation came the invisible blueprint of orbits and tides, a single relationship describing every dance between bodies in space. From Maxwell's equations came the revelation that light, magnetism, and electricity were one and the same, a trinity of movement written in curls and divergences. Those symbols were not decorations of knowledge, they were knowledge itself. When their shapes aligned, the universe responded. Astronomers and physicists began to realize that they could see with mathematics long before they saw with light. The discovery of Neptune came first from perturbations in Uranus's orbit, a mathematical prediction later confirmed by a telescope's lens. The strange precession of Mercury's path foretold Einstein's general relativity before he even began to write it. When equations fit perfectly, they began to act like instruments tuned to the hidden music of nature. Each symbol was a note, and together they created harmonies that could be heard only through reason. Then came the equations that reached beyond what anyone could imagine. When quantum mechanics emerged, it did so not from observation, but from necessity, an insistence that energy came in discrete steps, not in a continuous stream. The idea was absurdly simple, yet it explained the spectra of atoms, the colors of stars, and the stability of matter itself. Numbers that existed only on paper were suddenly dictating the behavior of everything that glowed, from candle flames to supernovae. The same happened with Einstein's equations of relativity. They did not merely describe gravity. They foretold phenomena that would take generations to confirm the bending of starlight, the dilation of time, the existence of black holes. Long before telescopes caught those events, the mathematics had already declared them inevitable. Each discovery was less a surprise than a realization. The universe had been announcing itself in numbers all along, and humanity was just beginning to listen with sufficient patience. This predictive power created a new kind of wonder, one deeper than spectacle. To find beauty in an equation was to trust that beauty was the scent of truth. When Dirac wrote his relativistic equation for the electron, he demanded elegance first, accuracy second. From that elegance came antimatter, a prediction no one had asked for, but one the universe confirmed decades later. It was not a coincidence. Beauty was turning out to be reliable. The pattern grew clearer with time. When equations were awkward, filled with special cases and exceptions, they tended to collapse under scrutiny. But the elegant ones, the ones that balanced symmetry with simplicity, survived. The inverse square law of gravity, Maxwell's field equations, Schrödinger's wave equation, Einstein's relativity, all were concise, self-consistent, almost musical. They were not written in the language of chance, but in the grammar of inevitability. The cosmos spoke sparingly, and its brevity was its perfection. As technology advanced, these numbers began to reach further, predicting not just motion and light, but existence itself. The search for subatomic particles followed the paths drawn by equations decades before. The Higgs boson, the neutrino, the quark, all had their names whispered in mathematics long before machines confirmed them. The universe seemed to allow discovery only after it had been imagined. And every time an experiment verified a prediction, the bridge between imagination and nature grew stronger. Yet there was humility in these triumphs. For every success, new mysteries emerged, numbers that worked but had no clear meaning, constants that seemed arbitrary yet necessary, patterns that hinted at deeper laws still hidden. Why should the speed of light, the strength of gravity, or the charge of the electron take exactly the values they do? Change them slightly, and stars would never form, chemistry would collapse, and life would be impossible. The precision was almost suspicious, as though the equations were tuned to allow beauty itself to persist. This tuning inspired both awe and unease. The fine structure of the cosmos felt intentional, though no intention was evident. The laws were impartial, but their outcomes were generous galaxies, colors, consciousness, and the capacity to notice all of it. The equations that predicted nebulae also predicted the atoms of the brain observing them. In the act of understanding, the universe became aware of itself. Numbers were no longer distant abstractions. They were the reflections of being written into the pattern of reality. Somewhere between mathematics and starlight, a quiet realization began to form that knowledge itself was a form of beauty, and beauty, in turn, a form of understanding. When the universe allowed its rules to be expressed through numbers, it created a bridge between matter and meaning. The same logic that guided the fall of planets also guided the rhythm of thought. To read an equation, to glimpse its curve and balance, was to see the structure of creation laid bare, not as mystery diminished, but as wonder deepened. Every time a number revealed something true, the cosmos seemed to grow a little more intimate. Each discovery folded the infinite into the human scale, turning unreachable distances into expressions that could fit on a page. In those pages, nebulae glowed, electrons danced, and gravity curved the path of time itself. The universe, through mathematics, was learning how to describe its own reflection, and in that reflection, the restless mind could finally find stillness, for to grasp even a fragment of such precision was to feel that beauty and truth were not two paths, but one. As the 20th century drew on, scientists began to sense something uncanny, a quiet conspiracy between mathematics and the world it described. It was Eugene Wigner who gave voice to the question that had haunted generations of thinkers. Why should human symbols written in chalk on blackboards so effortlessly anticipate the behavior of the universe? The question itself sounded simple, yet its implications reached into philosophy, consciousness, and the possibility that reality might be written in a language that predated us. The more physics advanced, the more this mystery deepened. Equations crafted for elegance alone began predicting the existence of things no one had seen. Einstein's field equations, concise and symmetrical, foretold gravitational waves that would not be confirmed for a century. Dirac's pursuit of mathematical beauty led him to antimatter, an idea so strange it bordered on science fiction. Maxwell's unification of electric and magnetic fields produced light itself as a natural consequence, decades before anyone could prove it. The universe appeared to not only tolerate these creations of the mind, but to obey them. It was as though mathematics were not invented, but discovered an architecture that existed before thought, waiting patiently for attention. The scientist did not create truth, but uncovered it. brushing dust from the carvings of an eternal temple. Even randomness bowed to these laws. The motion of gases, the decay of particles, the orbits of planets all followed equations so precise that deviation seemed impossible. Order ran deeper than perception. The uncanny alignment between thought and cosmos raised a quiet suspicion. Perhaps intelligence and the universe shared ancestry. Maybe the mind's capacity for pattern was not an accident but an echo. The same logic that governs stars might govern neurons. The same equations that shaped galaxies might whisper through the architecture of awareness. If consciousness was born of matter, then the laws that built matter had already written the syntax of thought long before thought began. Still, many resisted this idea. To them, mathematics was a tool useful, yes, but not mystical. It worked because humans designed it to fit their observations. Yet that explanation faltered when numbers began predicting realities far beyond human experience. The equations for quantum electrodynamics, for instance, reached precision so astonishing that if their results were off by a hair's breadth, every atom in the universe would misbehave. But they were not off. They matched experiment to 11 decimal places, as if the cosmos were running code too elegant to fail. This perfection created unease as much as awe. How could mindless particles follow such exquisite arithmetic? Why should empty space hum with fluctuations that obey equations meant for human comprehension? Some argued that mathematics was merely a reflection of how the brain compresses, experience an evolutionary advantage that happened to map well onto nature. But others suspected something grander, that the universe was not just describable by mathematics, but built from it. The philosopher's question returned in a new form. If everything that exists follows equations, then what are those equations themselves made of? Are they merely abstractions, or are they the scaffolding of being? When a wave moves across a pond, is it the water that moves, or the information about motion? Increasingly, physicists began to suspect that information, not matter, was the true currency of reality. Numbers were not reflections of the world, they were its skeleton. Even randomness, once thought to defy law, began revealing hidden order. Quantum uncertainty did not mean chaos, it meant probability structured by mathematical rules. The dice of nature were not free to fall just anywhere, they rolled within precise boundaries, governed by wave functions and symmetries. Beneath apparent disorder lay a choreography so subtle it appeared spontaneous. Beauty was not the absence of chance, but the taming of it. The power of mathematics reached far beyond the visible. It allowed scientists to predict realms utterly alien to intuition. Black holes where space curved upon itself, subatomic fields vibrating with virtual particles, the stretching of space-time during inflation. Every time reality was pushed to its limits, mathematics followed seamlessly, as if it had already been there. The human mind was not forcing logic onto the cosmos. It was following a trail already laid. The recognition of this bond brought a peculiar peace. It meant that understanding was not rebellion against nature, but participation in it. To solve an equation was to echo creation. To recognize a pattern was to momentarily align with the symmetry that sustains existence. Every insight, every theorem, every curve drawn through data was a small act of resonance with the universe's own thinking. At night, when the instruments were silent and the world dimmed, many scientists confessed to a feeling of reverence. They were not worshipping in the traditional sense, they were listening. The hum of the cosmic background, the precision of an orbit, the whisper of constants all spoke in the same soft cadence. The world was not built from chaos painted with order. It was built from order that learned how to breathe. Wigner's unreasonable effectiveness remained both question and comfort. Perhaps it was unreasonable only to the human ego, still astonished that it could understand at all. Maybe the universe was not separate from mind but continuous with it, an unfolding thought so vast that its equations became galaxies, its constants became stars, and its awareness became us. In that view, beauty was not evidence of coincidence, it was evidence of kinship. The pursuit of beauty in science had, for centuries, felt like a compass that always pointed toward truth. Yet, as the 20th century ripened into the 21st, a quiet unease began to ripple through that conviction. For all its grace, beauty had also misled. It had lured minds into symmetry too perfect, simplicity too seductive, equations too clean to be real. The universe, after all, was not obliged to please the human eye. It was only obliged to exist. The warning came not from poets, but from scientists themselves. The history of physics is littered with ideas that glittered but failed. Elegant formulations that promised unity ended in contradiction. Beautiful models crumbled under the weight of stubborn data. Each disappointment was a reminder that the cosmos did not answer to aesthetics, it answered to evidence. The dangerous lure of beauty lay in how easily it could replace understanding with satisfaction. Einstein himself fell into that trap. His equations of general relativity had been so exquisite, so perfect in their geometric simplicity, that he could not let them go. When quantum mechanics emerged, full of indeterminacy and chaos, he resisted. God does not play dice, he said, not as a declaration of faith, but of taste. The randomness of quantum theory offended his sense of elegance, yet nature seemed indifferent to elegance. The dice, it turned out, rolled endlessly in the quantum dark, producing results that matched experiment after experiment. Even within that apparent chaos, physicists found that the universe's beauty might lie not in simplicity but in depth. Quantum mechanics was messy on the surface, but beneath its strangeness lay a hidden precision. The probabilities, though unpredictable individually, averaged out with uncanny consistency. The math was still beautiful, just not in the way Einstein had hoped. It was a beauty of honesty, not perfection. The universe's order was not ornamental, it was functional. Later, entire generations of theorists chased beauty into deeper jungles. The dream of unification of one equation to explain all forces became the grail of modern physics. String theory emerged from this desire, shimmering with mathematical symmetry, its equations curling through extra dimensions invisible to the senses. It was breathtakingly elegant. Yet as the decades passed, evidence remained silent. No experiment confirmed it. Its beauty grew almost suspicious, as though nature were refusing to be domesticated by aesthetic preference. Some physicists began to wonder whether beauty had become a distraction. Perhaps nature was not minimalist, but exuberant. Perhaps the universe was not a perfect sphere of order, but a vast garden of asymmetries, chance events, and half-solved compromises. The orbits of planets might appear neat, but the formation of galaxies was turbulent. The rules of particles might seem precise, but they rested on constants whose origins no theory could justify. The deeper science looked, the more the universe resembled not a finished painting but an evolving improvisation. And yet, the human mind could not abandon its love for elegance. It was wired for pattern, for economy, for the sense that truth should feel right. Even the most pragmatic physicists found themselves seduced by the idea that beauty might still be a valid clue. History's greatest theories had all shared it. Why stop believing now? But doubt had matured into humility. Beauty was not a guarantee, it was a hint, a clue, not a command. The debate over beauty's role became philosophical. Was mathematics beautiful because it mirrored the universe, or because human minds had evolved to see coherence as pleasure? Did the equations reveal something fundamental about reality, or merely something about perception? The answer remained uncertain, shimmering like heat above a desert road. Beauty might be the bridge between mind and matter, or it might be a mirage hovering over our longing for order. In the laboratories, the tests continued. Every elegant equation had to submit to the rude clarity of experiment. Sometimes beauty triumphed, sometimes it fell. The standard model of particle physics, for all its success, was often called ugly, patched together from constants and couplings that looked arbitrary. Yet it worked. Its inelegance was its truth. And this, perhaps, was the deeper lesson, that the universe's beauty could include imperfection, that symmetry could be broken and still be whole. From this realization grew a new kind of appreciation. The elegance of the cosmos was not in its simplicity, but in its ability to contain both order and disorder without collapsing. The laws of physics were not a hymn to perfection, but a testament to resilience. The same asymmetries that broke balance gave rise to stars, elements, and life. Flaws became origins, imperfections became structure. So beauty, humbled, found its truer place. It was no longer the ruler of truth, but its companion, a guiding warmth that encouraged exploration, not a throne that demanded worship. Science learned to listen more than to admire. It allowed data to contradict dreams, equations to surprise their creators, and randomness to coexist with reason. In that humility, beauty deepened. To seek truth now was to walk a quieter path, one that welcomed elegance but feared idolatry. The universe did not promise to be beautiful in every corner, yet the search for beauty remained an act of love, a human instinct to find coherence in chaos. And perhaps that instinct itself was part of the design, for even when elegance deceives, it still leads the mind outward, toward questions, toward discovery, toward awe. The urge to measure the universe began with curiosity, but it matured into a need for orientation, a longing to know where and when we truly are. The night sky, once infinite and ungraspable, began to yield its distances, not through myth, but through light. Every star, every galaxy, carries within its glow a timestamp, a memory of how far its photons have traveled. To map those journeys was to sketch not a geography, but a history, a cosmic diary written in wavelengths and redshifts. Early astronomers could only guess at scale. Stars appeared eternal and unchanging, their patterns steady across human generations. But then came a quiet revolution, led by a woman in a Harvard observatory, who found that the rhythm of a certain kind of star could be used as a ruler for the cosmos. Henrietta Swan Leavitt, studying thousands of variable stars on glass plates, noticed that the brighter ones pulsed more slowly. She had discovered the key to the universe's first yardstick, the period luminosity relation of Cepheid variables. This relation allowed light to become a measure of distance. By comparing a star's intrinsic brightness to how faint it appeared, astronomers could calculate how far away it was. Leavitt's insight was elegant and humble, yet its implications were boundless. It meant that the universe was no longer a backdrop. It was measurable, dimensional, alive with depth. Light was not merely beauty, it was geometry unfolding. A decade later, Edwin Hubble stood at Mount Wilson Observatory and used Leavitt's rule to measure the distances of galaxies. What he found shook the foundations of everything known. The farther a galaxy was, the faster it seemed to be receding. Space itself was stretching, carrying entire galaxies along with it. Redshift, the lengthening of light's wavelength, became the telltale sign of expansion. The universe was not static, it was breathing outward. This discovery altered not just astronomy, but philosophy. For centuries, the cosmos had been imagined as eternal, unchanging, a divine architecture fixed in perfection. Now it was revealed to be dynamic, restless, full of motion. Time was not merely flowing within the universe itself was flowing through time. Each galaxy became a note in an expanding chord, each photon a messenger from a younger version of reality. Astronomers began to build what they called the cosmic distance ladder, a hierarchy of methods for measuring deeper and deeper into space. Parallax for nearby stars, Cepheids for distant galaxies, supernovae for the farthest reaches of light. With each rung, the map of existence grew clearer and more haunting. The further one looked, the younger the universe became. Light from a galaxy 10 billion light-years away was 10 billion years old. To gaze outward was to look backward in time. Every observation was archaeology across the abyss. This idea was both comforting and vertiginous. The night sky was not a view of now, but a mosaic of thens, a collection of moments frozen at different ages of the cosmos. Even the light of the moon was old by a heartbeat, that of the sun by 8 minutes, the nearest star by 4 years. Nothing was simultaneous. Existence itself was layered in delay. To look up was to see the past still shining, indifferent to the present that received it. With redshifts came a revelation even deeper. If the universe is expanding now, it must have been smaller before, perhaps unimaginably small, dense, and hot. This realization gave birth to the concept of the Big Bang, not as an explosion in space, but as an expansion of space itself. Every point was once closer to every other. Every atom shared an origin. The cosmic map was not a static image. It was a movie in slow motion, unfolding frame by frame across billions of years. Measuring became an act of listening. Telescopes turned into time machines. Each improvement in resolution pushed human sight further back toward the dawn. Distances ceased to be emptiness between things. They became time made visible. Light, stretched by expansion, arrived redder and fainter. like a voice from across eternity. To measure that fading was to trace the pulse of the cosmos itself. But as the data grew, the picture became stranger. The universe's expansion was not steady, it was accelerating. Galaxies were drifting apart faster than expected, as though an invisible force were urging them onward. Distance, once a simple geometry, had become a dynamic mystery. Redshifts no longer traced only motion, they traced the influence of something unseen, a soft pressure suffusing the fabric of space. The map of all distances thus became a map of tension between gravity's pull and this new, repulsive influence. Space was both connective and divisive, both cradle and separation. Every point in the universe moved away from every other, yet the pattern remained consistent, like dots expanding on the surface of a growing balloon. The geometry was elegant, but the meaning was strange, and so the act of measurement became both science and meditation. Each number on the map carried awe, a silent recognition that the universe was not simply large but active, ceaselessly rewriting its own coordinates. The light that entered the eye or the telescope had traveled through epochs, crossing regions where stars were born and died, where space itself had stretched by factors of 1,000. It had endured. The cosmic distance ladder, fragile and luminous, became humanity's most delicate bridge across time. It did not just tell where galaxies were, it told when they were. It turned the night sky into a living timeline, an illuminated history written in color and delay. To follow those measures was to realize something profound. The farther one looked outward, the closer one came to the beginning, and the more that beginning began to look like a promise, still unfolding, across the endless distances of now. It began as a faint unease in the data. The galaxies, already known to be receding, were not simply moving away, they were speeding up. The universe was expanding faster and faster, as if pushed by an invisible hand. For most of history, gravity had been understood as the great unifier, the cosmic glue that kept the heavens from flying apart. But now, the evidence whispered a new and disquieting truth. Something unseen was countering gravity's pull, not with violence, but with gentleness. A quiet force, smooth and steady, was urging the cosmos to drift outward into ever deeper stillness. In 1998, two independent teams of astronomers set out to measure the universe's deceleration, a natural slowing expected from the gravitational attraction of matter. They used distant supernovae as standard candles, luminous beacons whose intrinsic brightness was known, to measure cosmic distances. But when the light reached them, it was dimmer than prediction, farther away than models allowed. The conclusion, once verified and re-verified, seemed impossible. The expansion of the universe was not slowing down, it was accelerating. The cosmos, it seemed, was not merely growing, it was being gently inflated by something pervasive and invisible. This new player in the cosmic story was called dark energy. It made no sound, emitted no light, and yet accounted for nearly 70% of all that existed. The name was not poetic, but honest. We knew it was there, but not what it was. At first, scientists wondered if the effect could be explained by Einstein's long-discarded cosmological constant, a term he had once inserted into his equations to keep the universe static, and later called his greatest blunder. But now, it seemed, that blunder might have been prescient. The constant could represent the energy of empty space itself, the vacuum's quiet insistence on expansion. Perhaps nothingness was not empty after all, but full of potential, a sea of energy invisible to every instrument except mathematics. If true, this vacuum energy was astonishingly gentle. Its pressure was unimaginably weak on human scales, weaker than a whisper on a mountain breeze. Yet across cosmic distances, it became dominant, stretching space with persistent calm. Galaxies that had once been bound together began to drift apart, their light redshifting into deeper and deeper hues, until even their faintest glow would vanish from sight. The night sky, long thought infinite, was slowly erasing its own memories. The discovery rewrote the future. If this acceleration continued, distant galaxies would recede beyond the horizon of visibility, leaving only the local group, the Milky Way, and its few neighbors, adrift in a darkening void. The cosmic background radiation would fade into wavelengths longer than any receiver could detect. Future astronomers, billions of years from now, might gaze into a sky empty of evidence that an expansion ever occurred. The universe, in its vast solitude, would become unknowable again. Yet there was beauty in this quiet doom. The force that threatened to dissolve the visible universe did so without destruction. It did not tear. It opened. It was not a storm, but a sigh. Space expanded not as violence, but as breath, the universe inhaling infinity. The galaxies drifted apart not because they were flung, but because the very fabric beneath them was stretching, like the surface of a balloon between two dust motes. This acceleration was not chaos. It was choreography. Still, the mystery deepened. What was dark energy? Was it a true cosmological constant, an inherent feature of space-time, or was it something dynamic, a field that evolved over time? Could it someday weaken, allowing gravity to reclaim dominance, or would it grow stronger, tearing even atoms apart in a big rip? The data could not yet decide. Each possibility carried its own poetry, a universe eternally expanding, or one that dissolves in its own yearning for freedom. Some physicists imagined dark energy as a quantum whisper, the energy of countless virtual particles flickering in and out of existence in the vacuum. But when they tried to calculate its magnitude, their equations overshot by 120 orders of magnitude, the most spectacular mismatch in all of science. The vacuum seemed to be humming far more quietly than expected. Why it was so precisely tuned enough to accelerate the universe, but not enough to tear it apart, became one of the deepest puzzles of all. In that silence, the universe revealed a strange compassion. Expansion allowed stars to live longer, galaxies to form safely apart, and complexity to emerge without collapse. If the cosmos had been too dense, gravity would have rained everything back into fire, too empty, and matter would never have gathered. Instead, it balanced itself delicately between those extremes, a geometry of grace. Dark energy's gentle push was not destruction, but permission. It allowed time to stretch, to make room for story, for evolution, for reflection. To lie under the stars and know that the sky is slowly widening is to feel both small and blessed. The same force that carries galaxies away also carries light to us, across billions of years. Every photon we see has outrun that expansion long enough to arrive, like a message delivered just in time. Each night's starlight is a victory over dark energy's drift, a reminder that for now and perhaps for a long while yet connection remains possible. The universe's acceleration is its softest act and its grandest mystery. It is the slow opening of an eternal flower, its petals unfolding beyond what any eye will ever see. And somewhere within that expansion, amid the gentle pull between gravity and emptiness, beauty endures not as stillness, but as motion that never ends, a balance between presence and disappearance, between light and the vast, patient dark. In the beginning, everything was symmetrical. The infant universe, still incandescent from its birth, held balance so perfect that matter and antimatter existed in equal measure. Energy moved without preference, and every direction was the same as any other. It was a moment of pristine neutrality, a silence before differentiation, yet that silence could not last. Perfection, it seems, is unstable. From the smallest tremor, in those first fractions of a second, symmetry broke, and from that fracture, the universe was born anew. Symmetry breaking became one of the most important revelations in modern physics, the quiet key to why anything exists at all. If the universe had remained perfectly symmetrical, all matter would have annihilated with antimatter, leaving behind only radiation, no galaxies, no stars, no life. Instead, for reasons still partly unknown, something tipped the scales. For every billion antimatter particles, there were 1,000,000,001 particles of matter. That single imbalance, that microscopic asymmetry, became everything we now see. Physicists learned that breaking symmetry does not mean destruction, but creation. When perfect balance shatters, new laws emerge, new possibilities unfold. In the high temperatures of the early universe, forces that now seem distinct, gravity, electromagnetism, the strong and weak nuclear forces were united in elegant simplicity. But as the cosmos expanded and cooled, that unity fractured. Each force froze out like crystal from molten glass, acquiring its own character and domain. The complexity of nature was born not from chaos, but from the deliberate unbraiding of perfection. This process can still be witnessed in particle accelerators, where conditions close to those first moments are briefly recreated. In those collisions, physicists glimpse how particles gain mass, how fields condense, how diversity arises from uniformity. The Higgs field, a pervasive energy that gives weight to matter, was once in perfect symmetry with all else, a silent ocean where particles moved massless, unbound. When that field froze, symmetry was broken, and mass appeared like dew forming on invisible grass. The universe became tangible, textured, and slow enough to build structures. Symmetry breaking also explained why the cosmos could have direction and story. A perfectly symmetrical universe would be timeless, nothing could change, for all would be identical. But the slightest imperfection introduced an arrow, a before and an after. Entropy could grow, stars could ignite, life could evolve. The fracture gave time permission to flow. Balance, once shattered, became narrative. The universe learned how to remember. Even within this fragmentation, traces of the original symmetry remain subtle correspondences that bind the broken pieces together. Every particle has its counterpart, every force its echo. The equations that govern them are like reflections in rippling water, distorted yet recognizable. Physicists pursue these reflections through the concept of unification, the belief that the many are still secretly one, and that somewhere beyond our reach, perfect symmetry still waits. The breaking of symmetry also gave rise to the particular beauty of the world. Snowflakes, crystals, galaxies, living bodies all owe their form to the tension between order and imperfection. Perfect symmetry is sterile, broken symmetry is creative. In its fractures lie pattern, rhythm, and variation. The spiral of a galaxy, the double helix of DNA, the branching of trees each repeats with difference, a motif of imbalance turned art. The cosmos does not fear imperfection, it uses it as a brush. At cosmic scales, symmetry breaking became the architect of matter itself. Slight differences in density within the early plasma caused gravity to pull unevenly, leading to the first stars. Without those irregularities, light would never have condensed into structure. The same principle applies at every level, from the arrangement of atoms in a crystal to the arrangement of galaxies in the sky. Perfection cracked, and through the crack, beauty entered. There is an elegance in the way symmetry breaks. It does not shatter into chaos, but divides into order upon order. When physicists map these transitions, they see hierarchies of possibility forces differentiating, particles emerging, constants settling into values that seem chosen with impossible care. Change follows pattern, even as pattern dissolves. The universe remains coherent while reinventing itself, as if improvisation were built into its score. Some philosophers have suggested that this principle might be the universe's most profound truth, that creation requires imbalance, that the price of existence is asymmetry. Without it, there could be no contrast, no movement, no difference between something and nothing. Perfection, in its static serenity, can only dream. Imperfection is what dreams into being. Even consciousness may owe its existence to broken symmetry, the asymmetry between knowing and unknowing, between observer and observed. Awareness itself might be the latest echo of that first imbalance, the cosmos continuing to unfold its own differentiation in the form of thought. If so, then every act of perception is another ripple in that ancient fracture, the universe continuing to explore what it became when it decided not to remain still. The gentle push of dark energy, the formation of galaxies, the heartbeat of life, all may be consequences of that first imperfection. The cosmos began as a perfect note and became a symphony because it allowed dissonance to enter. Out of broken symmetry came diversity, out of diversity came complexity, and out of complexity came meaning. To look at the night sky with this in mind is to see not stillness, but motion caught in equilibrium. Stars burn because the universe once blinked. The balance that was lost at the beginning continues to echo in every photon that reaches us. Symmetry broke, and in breaking, it became possibility. What was once flawless became alive. In the smallest spaces of existence, reality trembles. There, beneath the calm of stars and the certainty of equations, lies the quantum world, a place where the universe murmurs in probabilities instead of statements. Nothing here is fixed, nothing here is still. Particles flicker in and out of being like thought, and the vacuum hums with invisible energy. The familiar fabric of matter dissolves into waves of possibility. It is a world so delicate that to observe it is to change it, and yet from this uncertainty rises the structure of everything solid and sure. The early architects of this strange domain, Planck, Schrödinger, Heisenberg, Bohr, approached it not as conquerors but as translators. They had glimpsed a reality that did not behave like matter at all, but like music. Energy came in quanta, discrete notes that could combine, interfere, or vanish. Electrons existed not as marbles orbiting nuclei, but as clouds of potential, probability waves describing where they might be found. Nothing in this microscopic world happened with certainty. It happened with rhythm. The equations of this new physics, the wave equation, the uncertainty principle, the superposition rule carried an elegance both serene and unsettling. They described not what was, but what could be. Each particle was a sum of possibilities until measured, when one outcome crystallized into being and all others evaporated. Observation did not merely record reality, it helped create it. Existence was participatory, woven together by attention itself. This revelation shook science to its philosophical roots. The universe was not a machine grinding predictably forward, but a tapestry of probabilities that only became real through interaction. The act of looking, of measuring, of caring to know, became a creative force. Matter and meaning, once thought separate, turned out to be entangled. Every particle carried both wave and corpuscle, both presence and potential, both silence and song. In the midst of this paradox, beauty persisted. The mathematics of quantum theory was astonishingly pure, linear, symmetrical, and compact. The wave functions that governed particles behaved like melodies, adding and cancelling, harmonizing across dimensions invisible to sense. Out of their interference patterns arose the colors of atoms, the shapes of molecules, the glow of stars. The physical universe was not built of bricks but of harmonics. Reality, at its base, was a kind of music too fine to hear. Heisenberg once said that the first gulp from the glass of natural science will make you an atheist, but at the bottom of the glass, God is waiting. He did not mean a deity of religion, but the sense of wonder that returns when reason reaches its limit. The deeper scientists peered into quantum fields, the more they realized that certainty was a mirage. Particles had no paths, only probabilities. Even empty space was alive with motion virtual pairs appearing and vanishing like dreams. The void itself shimmered with potential. It became clear that the vacuum was not nothingness but the stage of everything. Every field electromagnetic, gravitational, nuclear vibrated even when empty. Space was filled with zero-point energy, a faint hum of existence that could never be turned off. Out of that background, fluctuations could blossom into particles, and those particles could condense into matter, stars, galaxies, and thought. The universe was not built upon emptiness, but upon a low murmur of being that had never ceased. Quantum mechanics did not erase beauty, it redefined it. The symmetry of classical physics gave way to a deeper order, one that embraced ambiguity as essential. The uncertainty principle was not an obstacle, but an invitation, the universe choosing freedom over rigidity, diversity over determinism. Through uncertainty, creativity entered. Each quantum event was a small act of improvisation, a cosmic breath deciding, again and again, to continue. At larger scales, the quantum hum became the lullaby of stability. Electrons found orbits not by location, but by standing waves, patterns of vibration where probability settled into harmony. These harmonies determined the shapes of elements, the bonds of molecules, the properties of matter. In every stone, every leaf, every heartbeat, quantum music held the rhythm of endurance. The smallest fluctuations gave rise to the grandest forms. Entanglement revealed another layer of intimacy. Two particles, once connected, remained linked even when separated by light years. Measure one, and the other responds instantly, as though distance itself were an illusion. Reality, it seemed, was not local, it was whole. The universe was less like a collection of parts, and more like a single organism, experiencing itself from within. Information, not substance, might be its true fabric. The idea was both scientific and poetic. that existence was built on relationships, not on objects. Every atom was a node in an unbroken web of probabilities, every event an expression of the whole. To touch one part of reality was to stir all of it, subtly, invisibly. This was not mysticism disguised as physics. It was physics speaking the language of mystery. And so the quantum world, for all its strangeness, offered comfort. It showed that uncertainty was not emptiness, but fertility. Out of the unpredictable came pattern, out of the wavering came permanence. The same fluctuations that filled the vacuum with trembling energy had once inflated the young cosmos, shaping the galaxies. The same laws that governed the spin of electrons shaped the chemistry of life. At every level, the improbable gave rise to the real. In this view, the universe dreams through quantum probability. It drifts between possibilities until attention crystallizes one of them into form. Every breath, every photon, every heartbeat is the outcome of that ancient, ongoing dream. The cosmos hums quietly in its sleep, and what we call existence is simply the sound of it breathing. There are places where gravity no longer behaves like kindness, places where light hesitates, time slows, and the geometry of space folds inward upon itself. These are the boundaries of comprehension, black holes, the tidelines of time. They are not merely objects but conditions, the ultimate test of Einstein's vision of curved spacetime. To look at one, even through the mathematics that describes it, is to face the universe at its most silent and absolute. A black hole begins with a collapse. A star, having burned its fuel, can no longer resist its own weight. It implodes, compressing its mass into a volume so small that escape becomes impossible. Not even light can flee. What remains is not a thing, but a horizon, a surface marking the point of no return. Inside, all paths curve inward. Outside, space is distorted into a slow whirlpool of gravity, drawing matter and time alike toward the unseen center. Einstein's equations predicted these entities reluctantly. For decades, physicists doubted they could exist. They seemed too extreme, mathematical curiosities rather than realities. Yet the cosmos, it turned out, had been creating them since its earliest ages. Today, we know that almost every galaxy shelters one at its core, millions or billions of times the mass of the sun. These giants govern their surroundings not with violence, but with order. They anchor galaxies the way a heartbeat anchors life. To fall toward a black hole is to experience the distortion of every familiar rule. Time for the falling object slows relative to a distant observer. From afar, it appears to freeze on the edge of the event horizon, its light stretched and reddened until it fades into invisibility. To the falling traveler, however, time flows normally until it ends. The horizon is not a surface one could touch, but a boundary between worlds, one side ruled by causality, the other by silence. Inside that silence, equations become hesitant. The laws of physics, gravity, quantum mechanics, thermodynamics begin to argue. At the singularity, the center where all matter collapses, densities become infinite and space-time ceases to have meaning. The known vocabulary of science breaks apart. No equation, however elegant, can yet describe what truly happens there. It is the blank space in the script of the cosmos, the word that cannot be written. And yet, paradoxically, black holes radiate order. They obey simple universal laws of their own laws of area, mass, and entropy. Stephen Hawking and Jacob Bekenstein discovered that black holes are not entirely black. They have temperature, entropy, and can emit faint radiation due to quantum effects near the horizon. This insight joined gravity with quantum theory, hinting at a deeper unity still unseen. The event horizon became not a boundary of destruction, but of information. In that information lies one of the greatest enigmas of all. If black holes evaporate through Hawking radiation, what happens to the information about everything that has fallen in? Quantum mechanics insists that information cannot be destroyed. General relativity seems to disagree. The information paradox stands as one of the central riddles of modern physics, a quiet war between two pillars of understanding. Somewhere within that conflict lies the key to the next revolution. But black holes are not only puzzles, they are performances. They shape galaxies, trigger star formation, and drive the evolution of cosmic structure. When two of them collide, space-time itself rings like a bell, sending gravitational waves across the universe, faint ripples in the very fabric of reality. We have heard these ripples now, captured by instruments sensitive enough to feel distortions smaller than a proton. Each detection is the echo of a colossal union, billions of light years away, a silent music of space and time merging. The beauty of black holes lies in their contradictions. They are both destroyers and preservers, chaos and clarity. Their simplicity is deceptive. Each can be fully described by only three numbers: mass, spin, and charge. Yet they embody the most complex physics known. They are prisons for light and laboratories for theory. They mark the limit of knowledge and the promise beyond it. To contemplate them is to feel time bend inward. The event horizon becomes a mirror in which the universe contemplates its own edges. Within, the known dissolves. Without, everything else revolves. The black hole's gravity is not a pull toward death, but an invitation toward understanding. It is the cosmos demonstrating what happens when the laws of nature are pushed to their purest form, when space becomes so curved that it folds back into thought. Even in their darkness, black holes are among the most luminous phenomena we know. When matter spirals toward them, it heats to millions of degrees, releasing torrents of radiation that outshine entire galaxies. The edge of absence becomes a ring of brilliance. Images from telescopes, like the Event Horizon, telescope's first view of M87's central black hole, reveal that light can dance on the brink of oblivion, orbiting before it fades. The boundary between being and nothingness glows. Perhaps that is their final lesson, that even the universe's most ruthless laws produce beauty when seen clearly. Gravity, left to its own devices, creates not just collapse, but coherence. The black hole, ultimate emblem of loss, becomes also a symbol of unity. All paths converge there, all distinctions vanish, all time flows to a single point. It is the purest expression of inevitability, the geometry of surrender. And yet, beyond the event horizon, something still happens, something no observer can ever record, but which the universe continues to write. Black holes are not the end of knowledge, they are its frontier. They remind us that beauty does not only reside in what can be seen or proven, but also in what resists comprehension. Within their silent depths, the cosmos keeps its oldest secret, that every collapse may be the beginning of another kind of light. For decades, black holes had been thought of as prisons of light, perfect absorbers, eternal silences from which nothing escaped. They were cosmic endpoints, devouring but never returning, the graveyards of energy and information. Then, in the mid-1970s, a new voice rose in the conversation, quiet but seismic. Stephen Hawking, exploring the marriage of quantum mechanics and general relativity, found that these cold giants were not completely silent after all, they whispered. They emitted. They glowed faintly in a radiation so subtle, it took theory itself to hear it. The discovery began not with observation, but with thought. Hawking asked what happened at the very edge of the event horizon, where space curved fiercely and quantum fields still hummed with invisible activity. In that precarious zone, virtual particles pairs that constantly appear and vanish in the vacuum could be torn apart by gravity. One particle might fall inward, the other escape outward. To the outside observer, this appeared as radiation, a steady trickle of energy leaking from the black hole's edge. This faint emission became known as Hawking radiation. It was impossibly gentle, weaker than the light of a candle compared to a sunday. Yet its implications were monumental. It meant that black holes could lose energy, shrink, and eventually evaporate. They were not eternal at all. Over inconceivable timescales, even the largest black holes would fade into darkness, leaving behind only the faint memory of their warmth. The most absolute boundary in nature had turned out to be porous. The universe, it seemed, refused to allow perfection. Even the most powerful structures had to obey thermodynamics, the rule that energy cannot vanish, only change form. A black hole possessed entropy, just like any other system, and with entropy came temperature. Jacob Bekenstein had first suggested this radical idea, arguing that the area of a black hole's horizon represented its disorder. Hawking's equations confirmed it. The surface area of the event horizon was a measure of the information hidden within. The larger the horizon, the more the black hole knew. From this, a strange poetry emerged. The darker the object, the more it contained. Entropy and knowledge became twins. A black hole, once thought to erase information, now appeared to store it on its surface, an immense library written in thermal whispers. But what language did it use? No one could yet read it. Theories multiplied, some suggesting that the universe itself might work the same way, that all of reality could be a vast, holographic projection where information on boundaries gives rise to everything within. The idea was dizzying. Reality as surface, space as record, existence as information written on invisible walls. If true, it would mean that everything galaxies, thought, love, even time, might be the unfolding of data stored at the edge of space. The black hole, once a symbol of obliteration, had become a teacher of preservation. Yet Hawking's revelation also exposed a paradox that shook physics to its core. If black holes evaporate, what happens to the information about everything that fell in? Quantum theory insists that information cannot be destroyed. But if the black hole fades entirely, where does that knowledge go? The information paradox became one of the deepest wounds in modern science, a rift between the two great pillars of understanding, quantum mechanics and relativity. Somewhere in that rift lies the key to unification. Hawking himself oscillated between certainty and surrender. He believed, then doubted, then believed again that information could be recovered, perhaps encoded in the subtle correlations of the outgoing radiation, perhaps imprinted in space-time's fabric itself. In the quiet hours of his illness, his synthetic voice carried ideas that touched the borders of metaphysics. Black holes, he suggested, were not the ends of knowledge but the bridges between its realms. The notion that radiation could emerge from such darkness redefined our concept of nothingness. The vacuum was not empty. The horizon was not void. The universe's most terrifying silence contained the faintest music photons, neutrinos, particles of light escaping against impossible odds. Each one was a note of defiance, proof that even in the deepest gravity wells, creation still found a way to speak. Over time, this realization softened the cosmic narrative. Death itself, stellar, galactic, or universal, began to look less like an ending and more like a transformation. When a black hole evaporates, its energy returns to the cosmos, diffused into radiation, redistributed as warmth. In that way, even destruction nourishes. The fire that once devoured worlds becomes a whisper that warms the void. Entropy, for all its inevitability, is not cruelty but balance. The image of Hawking's warm snow became a metaphor among physicists, a soft precipitation of radiation falling from the coldest places in existence. It evoked paradox, heat emerging from darkness, structure dissolving into information, time itself exhaling the memory of matter. To some, it sounded almost spiritual. To others, it was simply nature maintaining its symmetry in the strangest way imaginable. And yet, despite its gentleness, this radiation changed our sense of immortality. Black holes were not eternal monuments, they were stories with endings. Even the most titanic would one day vanish into equilibrium. Over timescales longer than galaxies could imagine, the universe would slowly smooth itself into quiet uniformity. Its dramas concluded. What remained would be the soft background hum of Hawking's revelation, the sigh of everything becoming one. Still, within that fade lies a form of grace. The cosmos, in allowing its most violent creation to dissolve peacefully, shows an elegance beyond human design. It does not cling to permanence. It evolves through impermanence, letting even its darkest forms return their energy to the whole. The black hole's final whisper, that faint, unseeable radiation, becomes a message for all existence. Nothing is ever truly lost. It only changes its way of shining. If the story of black holes taught that information could survive in the faintest glow, the next revelation whispered something stranger still, that all of reality might exist as a projection. The universe, some suggested, could be holographic, not solid in the way it appears, but encoded upon a distant surface, its depth an illusion born of perspective. This was not mysticism disguised as science. It was mathematics speaking in metaphors the human mind could almost grasp. The idea arose quietly, from the attempt to reconcile gravity with quantum theory. If information could not be destroyed, yet was somehow trapped at the edge of a black hole, Perhaps that edge, the event horizon, was more than a boundary. Perhaps it was a storage device, a two-dimensional sheet containing every detail of the three-dimensional world that fell within. Gerard Tooft and Leonard Susskind, studying these paradoxes, proposed that what happens inside any region of space could be entirely described by information on its surface. Reality, therefore, might not be volumetric, but superficial in the most literal sense. It was an unsettling thought. A galaxy, a mountain, a human being, all of it, possibly a holographic unfolding of data written on the fabric of space-time. The familiar world of distances and depths would be a kind of cosmic projection, like the moving patterns of light on the walls of Plato's cave. But instead of shadows cast by flame, they would be holograms cast by the mathematics of gravity and quantum entanglement. The more physicists explored, the more coherent the idea became. The holographic principle suggested that every cubic centimeter of space contains no more information than can fit on its boundary measured in Planck-sized pixels, unimaginably small bits of area. If one could somehow read that surface, every particle, every field, every motion inside would be known. The universe, at its root, would be a vast recording, its depth, an emergent illusion created by how information organizes itself. Even space-time itself, in this view, might not be fundamental. It could arise from the entanglement of quantum information geometry, born from correlation, curvature, shaped by connection. This was the insight of physicist Juan Maldacena, who discovered that a certain kind of universe with gravity could be exactly equivalent to one without gravity living on its boundary. The two descriptions were different languages telling the same story. The infinite and the finite were mirrors. The implications were immense. The deepest black hole and the smallest atom could be read as pages of the same text. The horizon of a black hole might hold not just the memory of what it had consumed, but the blueprint of space-time itself. What we call matter might be the visible script of hidden information encoded at the edge of existence. The entire cosmos, from the first light to the last whisper of radiation, could be one continuous computation, the universe writing and reading itself in real time. For the human mind, accustomed to solidity, this notion was both alien and intimate. We live within the hologram, yet we help sustain it. Every act of observation, every quantum interaction, every moment of awareness contributes to the entanglement that defines space and time. Consciousness, in this light, might not be a visitor within the universe, but a participant in its encoding. The fabric of reality includes the act of perception itself. Still, the beauty of the holographic principle was not in its strangeness, but in its balance. It reconciled what had seemed irreconcilable, the smooth geometry of Einstein and the granular probabilities of quantum theory. Two realms once thought opposed now appeared to be complementary projections of a single truth. Gravity and information were no longer rivals, they were reflections of each other, folded together like two sides of the same page. Philosophically, the concept resonated with ancient intuition that what we perceive as matter is appearance, that reality's essence lies beyond dimension, yet physics treated it not as metaphor but as mechanism. The equations worked. They explained entropy, black hole thermodynamics, and the correspondence between different theories of the universe. What once seemed poetic now became predictive. But there was something profoundly human in the idea as well. If all that exists is encoded at the boundaries, then nothing within is truly lost. Every event, every particle, every fleeting moment is written into the ledger of space-time. Death, decay, dissolution, these may simply be the reorganization of information into subtler forms. The universe forgets nothing, it merely transforms memory into pattern. To imagine existence as holographic is to find comfort in transience. The self, like the cosmos, is both projection and substance, both surface and depth. The lives of stars and people alike might be flickers within a grander recording, meaningful precisely because they are finite. Every birth adds a new line to the holographic script. Every disappearance becomes another equation written at the edge of time. When physicists look at this theory, they do not see illusion but economy, a universe that conserves not just energy but understanding. Space is not empty. It is the unfolding of information, translated into distance and duration. Light travels not through nothing, but through the texture of meaning itself. To study it is to read the geometry of comprehension. In the hush of observatories and the silence of minds confronting infinity, one feels the grace of this revelation. The cosmos might be vast beyond measure, yet its essence could fit upon a surface of pure relation. The holographic principle turns enormity into intimacy. The infinite written on the finite, the universe reflected upon its own skin. We are not outside that reflection, we are written within it. Every thought, every photon, every breath is part of the same projection light echoing from the edges of eternity. Long before galaxies shimmered or stars learned to burn, the universe lay veiled in a fog of hydrogen and helium, a vast, uniform sea without form or color. Darkness reigned, not as emptiness, but as potential waiting for ignition. For nearly 400 million years after the Big Bang, no starlight pierced this cosmic mist. Then, slowly, imperceptibly, the silence broke. From the faint ripples in density left by the infant cosmos, gravity began its patient work. The first light was about to be born. This epoch, known as the cosmic dawn, marked the universe's awakening from its long sleep. Tiny fluctuations in the ancient hydrogen clouds grew denser under their own gravity, drawing gas inward until temperature and pressure ignited nuclear fire. When the first stars flared, they transformed the nature of everything. Their radiance ionized the surrounding fog, tearing apart atoms, making the once opaque universe transparent. Light no longer wandered aimlessly. It traveled freely, announcing that creation had found its voice. These first stars were unlike any that exist today. Astronomers call them Population 3, stars immense, pristine, forged only from hydrogen and helium. They lived fast and died violently. Without heavier elements to cool them, they grew to hundreds of times the mass of the sun, burning with the blue-white brilliance of newborn divinity. Their lives lasted only a few million years, but in that brief time they sculpted the future. Through their fusion, the universe manufactured carbon, oxygen, iron, the alphabet of matter that would one day form planets, oceans, and life. When these giants died, they did not fade, they exploded. Their deaths scattered heavy elements across the void, seeding the next generations of stars. Each supernova was a forge, each remnant a promise. Galaxies began to assemble around these regions of enrichment, small clusters merging into greater spirals. Out of violent ends came structure and stability. The cosmos was learning to recycle itself, turning death into order. Modern telescopes, peering across 13 billion years of space and time, now glimpse the faint relics of that era. The James Webb Space Telescope, with its gold mirrors tuned to infrared light, has begun to catch glimpses of galaxies forming just a few 100 million years after the Big Bang. What it sees are not the grand spirals of the present day, but embryonic swirls, compact, chaotic, dazzling with the glow of creation's first furnaces. Each one is a fossil of illumination, a memory of when darkness first learned to shine. The light from those stars still travels toward us, stretched by expansion into longer, redder wavelengths. To detect it is to touch the oldest visible memory in existence. Each photon that strikes a telescope's mirror has journeyed for nearly the entire age of the universe, a survivor of time itself. The faint shimmer we now study in laboratories is the same radiance that ended the cosmic night billions of years ago. But the story of the cosmic dawn is not only one of astronomy, it is also a story of balance. The first stars were both creators and destroyers. Their radiation burned away the neutral hydrogen that had filled the universe, clearing the fog but also halting new star formation in nearby regions. Too much light could smother the next generation of stars before it began. The universe, in its infancy, had to learn moderation, the equilibrium between illumination and shadow. Out of that balance emerged diversity. As generations of stars lived and died, galaxies matured. They grew larger, more complex, more graceful. Within their arms, the chemical wealth of the first stars condensed into planets and moons, and eventually into the subtle architectures of life. Every atom of carbon in a living cell was once ash from a star that perished at the dawn of time. The glow that began in those first conflagrations has never truly gone out. It continues, reconfigured, within every flicker of consciousness. In this way, The cosmic dawn was not merely an event in the distant past, but an ongoing inheritance. Its light still threads through every sunset, every candle flame, every spark of thought. The first stars did not vanish. They diffused, transforming into the elements that now dream through us. To look up at the night sky is to see the descendants of those original fires, their lineage written across constellations and nebulae. Astronomers sometimes speak of the universe waking up at this stage. A poetic but accurate image. Before the cosmic dawn, there was only potential, like an instrument unplayed. With the ignition of the first stars, the universe found its rhythm. Space began to resonate with radiation, with cycles of birth and death, with harmony between gravity's pull and light's escape. The cosmic fog lifted, and in the clearing, the universe saw itself for the first time. And, in that seeing, it began the long process that would lead, billions of years later, to eyes capable of looking back upon it. The light that freed the cosmos from its darkness would one day fall upon retinas and mirrors, sparking questions and awe. Every observation, every dream of origin, is a reflection of that first awakening. The cosmic dawn was brief compared to the age of the universe, but its echo has never faded. It remains the silent pulse beneath all radiance, the moment when hydrogen discovered how to sing. The night sky, vast and cold, still carries that melody. To listen to it is to remember that illumination was not inevitable. It was chosen, quietly, by gravity and chance, by pressure and time, by the patience of creation itself. Long after the first stars burned, after galaxies settled into their slow rotations, the universe learned another way to speak. It began to speak not in light, but in rhythm vibrations in the fabric of space-time itself. These were gravitational waves, the faintest tremors imaginable, ripples that stretched and compressed reality as they passed. They traveled without resistance, crossing billions of years unblurred, carrying messages from cataclysms that would otherwise remain silent. If light was the universe's face, these waves were its heartbeat. Einstein had predicted them in 1916, woven naturally into his equations of general relativity. Massive objects, he said, could disturb space-time, like stones cast into a cosmic pond. The ripples would travel outward at the speed of light, altering distances ever so slightly, a star's orbit here, a planet's rhythm there. But the effect was so infinitesimal that for a century it remained theory, too delicate for any instrument to catch. For decades, physicists listened in vain for spacetime's music. Then, on the 14th of September 2015, the silence broke. Deep beneath the surface of the Earth, in long tunnels lined with laser beams and mirrors, the twin observatories of LIGO, the Laser Interferometer Gravitational Wave Observatory, registered a fleeting distortion. The pattern was unmistakable. Two black holes, each more than 30 times the mass of the Sun, had collided 1.3 billion light-years away. Their merger had shaken the fabric of existence itself. The signal lasted less than half a second, yet it told an entire story, two giants spiraling together, time slowing, space curving, energy released as pure vibration. Humanity had heard gravity sing. The sound, when translated into audio, rose and vanished like a sigh, a faint chirp, a cosmic heartbeat arriving after a journey across the eons. With that single note, an era ended. Astronomy was no longer confined to light. The universe had opened a new sense hearing. Not seeing, and through that hearing, new truths emerged. Gravitational waves are different from any other messenger. Light can be absorbed or scattered, matter can collide and decay, but spacetime's ripples pass through everything unhindered. They carry information not just about where events occurred, but about the nature of reality itself, the dance of gravity, the motion of mass, the curvature of time. They are the purest signals imaginable, undistorted and incorruptible. Each detection since has been a revelation. Colliding neutron stars, devouring black holes, and even the trembling of supernovae have all spoken through these invisible vibrations. Some waves are so ancient they may have come from the first seconds after the Big Bang, echoes of the moment when space itself began to expand. If we could hear those primordial ripples, we would be listening to the memory of creation. The instruments that capture these whispers are cathedrals of precision. LIGO's arms stretch 4 kilometers long, measuring distortions smaller than a fraction of a proton. When a gravitational wave passes, the space between its mirrors stretches and contracts by less than 1/10,000th of an atom's width. Yet even that is enough. Laser beams compare the distances, and from their interference pattern emerges the song of the cosmos. Each detection is an act of faith in measurement, a communion between mathematics and vibration. When two black holes merge, the amount of energy released in that brief moment surpasses the combined output of all the stars in the observable universe. Yet almost all of it escapes, as gravitational waves, soundless thunder, rolling through the continuum of being. No light marks the event, only space-time remembers. And so these waves carry a special purity. They are motion itself, stripped of matter and color, the bare music of existence. For the scientists who study them, each wave is both data and poetry. It tells of mass and spin, distance and duration, but also of inevitability, the way gravity's patience culminates in one final embrace. Every signal begins faintly, rising in pitch as two massive bodies spiral closer, then peaks in a crescendo as they merge, before fading into the hum of the universe once more. The pattern is always different, yet always familiar, as if the cosmos repeats a theme in infinite variations. This new astronomy has changed how we imagine our place in the universe. For the first time, we can sense events hidden from sight, black holes that emit no light, collisions that occur behind veils of dust, processes too ancient for photons to survive. We are listening directly to space-time, to the architecture of reality flexing under its own weight. In that listening lies a humility deeper than any visual wonder. The universe is not a picture, it is a symphony, and we are latecomers learning to recognize its key. There is something profoundly human in this discovery that to understand existence, we had to become quiet enough to hear it. The instruments do not look outward, but inward, through space itself, measuring its minute vibrations. The cosmos does not shout, it whispers, and only patience can translate its language. Every gravitational wave that passes through Earth distorts our planet, our bodies, our atoms, stretching and compressing us imperceptibly as it goes. We are, in a literal sense, participants in that song. Each moment, countless ripples flow through us from events so far away that they may have happened before Earth even existed. To live is to resonate. The discovery of gravitational waves has given the universe a new voice, one that transcends silence and sight. It is the voice of continuity, of everything connected by the thread of motion. Gravity, once seen as mere attraction, reveals itself as communication, the slow pulse of being exchanging messages across eternity. In that pulse, we find not chaos, but harmony, the soft silver thread that binds the stars, the galaxies, and every listening soul into one great vibration of time. In the quiet geometry of the cosmos, there exists a truth both simple and astonishing. Every atom in every living thing was forged in the heart of a star. Life is not an accident adrift among galaxies, it is an echo of stellar fire, the universe remembering itself through breath and motion. When one contemplates this, the distances between the human and the celestial vanish. We are not beneath the stars, we are their continuation. The story begins in the furnaces of those first generations of stars, where hydrogen and helium, the simplest elements, fused into heavier ones under unimaginable heat and pressure. In their cores, atomic nuclei collided, merged, and released energy, sustaining the star's glow. From these reactions came carbon, oxygen, nitrogen, iron, the very elements that would later form oceans, soil, lungs, and thought. Each heartbeat is a pulse of ancient fusion, each inhalation a reunion with history. When those massive stars reached the end of their lives, they collapsed and exploded as supernovae, scattering their enriched interiors across the interstellar medium. The shock waves seeded surrounding clouds with metals and dust, the raw ingredients of future worlds. Over time, gravity gathered these materials again, forming new stars with planets orbiting around them, solar systems built from recycled starlight. In one such system, a small world condensed from that dust and began to cool. Upon its surface, chemistry learned to dream. On that world, our world, the memory of those ancient fires still burns. It flickers in the metabolism of cells, in the red of blood that carries iron once fused in dying suns, in the calcium of bones once born in stellar cores. Even the photons that warm our skin are hand-me-downs from nuclear reactions at the heart of our own star, the Sun, a second-generation heir to those cosmic elders. Life is a consequence of continuity. The same processes that shaped galaxies also shape hearts. Astronomers often speak of the cosmic abundance of elements, the ratios of hydrogen, helium, carbon, and oxygen that fill the universe. Yet beneath those numbers lies a quiet poetry. The elements of life are the elements of beauty. The carbon that forms the lattice of organic molecules also forms diamonds. The oxygen that sustains breath also paints the skies blue. The same atomic structures that let leaves drink sunlight allow eyes to perceive it. Chemistry becomes emotion, physics becomes experience. To see life in this context is to feel both humility and belonging. The universe is not a cold machine indifferent to its products. It is an artist that builds with its own remnants. The atoms that once floated in stellar plasma now align themselves into the complexity of thought, composing music, language, love. Every human gesture is a reorganization of cosmic dust into pattern and purpose. We do not merely observe the universe, we perform it. Still, the conditions that allow this performance are fragile. Life exists only where balance is maintained, where gravity neither crushes nor releases, where temperature holds steady between freezing and flame, where molecules can bond without chaos. On Earth, these conditions are the result of delicate coincidences: a temperate orbit, a stabilizing moon, a magnetic field, a thin atmosphere. Yet such coincidences are not unique. Across the Milky Way, billions of planets circle their suns in the gentle zones where liquid water can flow. The potential for life, it seems, is written into the probabilities of existence. Astronomers now search for signatures of that possibility, spectral traces of oxygen, methane, and water vapor in distant atmospheres. Each detection is a whisper from another world, a hint that the universe may not be silent in its creativity. Life, if found elsewhere, would not diminish us. It would confirm that the cosmos is generous enough to repeat itself. The spark that began in one corner of time may have kindled in countless others. But even if we remain alone in the known night, the knowledge that we are made of stars is enough to dissolve solitude. The atoms within us have journeyed through cycles of birth and death, far longer than human memory. They have witnessed the inside of suns, the cold between galaxies, the glow of the first dawn. Life is the latest arrangement of those wanderers' consciousness, the brief moment when they can look back upon their travels and marvel. Some philosophers have said that life is the universe becoming aware of itself, that through biology, the cosmos studies its own reflection. If so, then our wonder is not incidental. It is the continuation of a cosmic impulse that began with light itself. Curiosity is gravity in another form, the pull toward understanding, the yearning for reunion. To seek the stars is simply to seek home. When night falls and the Milky Way stretches across the sky, the connection becomes tangible. Each glittering point is both distant and intimate, a reminder that ancestry is not limited to Earth. The hydrogen in our veins was born 3 minutes after time began. The calcium in our bones passed through a red giant's heart. The gold in our rings was forged in the collision of neutron stars, their light still echoing faintly through space. To wear gold is to wear the memory of cosmic violence transfigured into grace. Life, fragile as it is, carries a quiet defiance. Against entropy, against emptiness, it organizes, connects, remembers. It burns with borrowed energy, writes its brief stories, and returns its atoms to the cycle. Every life that ends becomes fuel for another. The universe loses nothing, it only rephrases itself. The death of a star gives rise to elements. The death of a leaf feeds new growth, and the death of a mind leaves thoughts that ripple outward through others. Existence recycles, meaning the way galaxies recycle light. To lie beneath the stars and breathe is to participate in that cycle consciously. The same gravity that binds galaxies holds our feet to the ground. The same light that built the early cosmos still courses through our bodies. There is no separation, only scale. Life, at its quietest, is not apart from the universe, but a continuation of its unfolding story. We are its pulse, its question, its reflection in motion. There is a point in the pursuit of understanding where numbers begin to resemble candles, small, steady flames burning in the vast dark of unknowing. Mathematics, more than any instrument, has been humanity's most enduring light. It does not merely describe the world, it reveals its skeleton. Every orbit, every rhythm of time, every flicker of starlight follows its quiet authority. Through it, the universe becomes readable, not as poetry alone, but as a kind of scripture written in precision. At first glance, mathematics appears detached, a discipline of symbols and rules. Yet to those who listen deeply, it hums with emotion. Each theorem is an act of trust, each equation an affirmation that order exists. When Newton wrote his laws, when Maxwell unified electricity and light, when Einstein curved space into time, they were not just solving problems, they were uncovering coherence. Beneath the apparent chaos of phenomena, they found symmetry and relationship, and in that harmony lay beauty as serene as any symphony. The mathematician's work resembles that of a monk illuminating manuscripts. Each line, each symbol, each careful assumption becomes a gesture toward transcendence. The equations of general relativity, compact yet infinite in implication, describe how mass bends geometry, how gravity is the shape of time itself. Schrödinger's wave equation, just as compact, describes how possibility crystallizes into being. These expressions are not inventions, they are discoveries, fragments of a language older than stars. And this language does not end with elegance, it evolves. Mathematics has become the bridge between the visible and the invisible, the known and the unimaginable. Group theory describes the hidden symmetries of particle physics. Tensor calculus shapes cosmology. Statistical mechanics reveals how chaos gives birth to order. The most abstract of ideas, imaginary numbers, complex manifolds, Hilbert spaces, turn out to describe the tangible world with frightening accuracy. Reality, in its bones, seems to trust mathematics completely. It is here that wonder deepens. Why should the universe follow these rules at all? Why should abstract relationships invented by the mind align perfectly with the behavior of nature? Wigner called this the unreasonable effectiveness of mathematics, the mystery that thought and cosmos rhyme. It suggests that the act of calculating is not separate from the act of being. The same logic that forms equations may be the logic by which the universe itself unfolds. Every discovery carries with it the same astonishment, that truth and beauty are twins. A messy equation seldom survives, a beautiful one often predicts something new. The inverse square law, the symmetry of Maxwell's fields, the curvature of Einstein's spacetime all share the same economy of form. It is as though the universe prefers simplicity, not because it is easier, but because it is purer. Simplicity, in this sense, is nature's poetry the way it speaks, when it does not have to explain itself. Yet mathematics is not merely descriptive, it is generative. New mathematical frameworks often precede the realities they describe. The Higgs boson was written long before it was found. Black holes were solved on paper before telescopes confirmed their shadows. Inflation theory, quantum chromodynamics, string vibrations all began as equations before they became evidence. To write a formula is to open a window onto a part of existence not yet visible. The universe seems willing to meet imagination halfway. In this partnership, mathematics becomes more than tool, it becomes companion. Scientists speak of equations as beautiful because beauty, here, means inevitability. When a pattern fits, when symmetry locks into place, there is a sense of rightness, not emotional alone, but ontological. It feels as though the equation has been waiting, timeless, for the human hand to uncover it. Discovery, in this light, is remembrance. The mind remembers what the cosmos already knows. Even the constants of nature, the speed of light, Planck's constant, the gravitational constant, appear tuned with astonishing precision, as though the universe had calibrated itself to allow comprehension. Change them slightly, and stars would not form, atoms would collapse, or chemistry would never awaken. The mathematics of reality seems balanced upon a knife edge of harmony. The cosmos is not random numbers scattered across infinity. It is a symphony tuned in the key of existence. But mathematics, for all its perfection, remains humble. It does not claim to explain why the rules are as they are. It only reveals that they are. Beyond the boundaries of each discovery lies mystery still untouched. In that sense, every solved equation is an invitation, an unfinished sentence that points toward the next layer of understanding. The closer one approaches certainty, the more one feels the warmth of humility. Perhaps that is its truest beauty. Mathematics offers both power and reverence. It allows prediction, yet demands respect. It defines the orbit of planets, but cannot define the meaning of their light. It reveals how time bends, but not why it flows. And in that limitation lies grace. For a universe fully explainable would be a universe without wonder, and mathematics, by reaching toward but never consuming truth, keeps wonder alive. Late at night, when astronomers run simulations or physicists balance equations under lamplight, they participate in a quiet ritual older than faith. Each variable, each symbol, is a candle against the dark, illuminating just enough to see the next step forward. The universe does not reveal itself all at once. It unfolds, number by number, curve by curve, into the mind that seeks it. To study mathematics, then, is to study intimacy, the meeting point of abstraction and reality, of thought and creation. It is the whisper of logic that echoes through galaxies, the hidden rhythm that keeps atoms bound and planets aligned. It is the soft handwriting of the cosmos across the blackboard of time, and as long as there is curiosity, that candle will not go out. Its flame will continue to burn, one equation at a time, lighting the path toward understanding, where mystery and clarity hold hands and refuse to let go. There are instruments on Earth so sensitive they can listen to atoms whisper and watch the universe form in the invisible. They do not see in the way eyes do. They translate. They take the silent signals that the cosmos sends: light too faint, radiation too cold, waves too long, and convert them into song, into color, into knowledge. These tools are the extensions of curiosity, the ways in which the universe looks back at itself through human invention. In mountaintop observatories, deserts, oceans, and even beneath the ice of Antarctica, these instruments stand like altars of attention. Radio dishes stretch their white spines toward the horizon, listening to frequencies that no ear could hear. Space telescopes float above the atmosphere, their mirrors polished to near perfection, capturing photons that began their journey before the Earth existed. Each one is an act of patience, a machine built to wait for light. The earliest telescopes were little more than lenses and hope. Galileo's crude glass revealed moons circling Jupiter and mountains on the moon. From that beginning, humanity's vision expanded outward, driven by the same question: what else is there? The answer kept unfolding with every improvement in precision. With optical telescopes came the revelation of galaxies. With radio antennas came the detection of the cosmic microwave background, the afterglow of creation itself. Later, X-ray and infrared observatories uncovered the hidden structures of the universe, the skeleton of black holes, the dust-veiled nurseries of stars. The Hubble Space Telescope transformed this exploration into art. Its images, deep and timeless, showed not empty darkness but abundance, galaxies scattered like jewels, nebulae blooming in colors that defied language. Every photograph was both data and prayer. Yet even Hubble could not see the first galaxies. Their light was stretched too far into the infrared. That task fell to its successor, the James Webb Space Telescope, whose golden mirrors now gather light that has traveled for over 13 billion years. Through it we peer into the youth of existence itself, watching the first structures form out of fog. Each new instrument reveals another octave of the cosmic symphony. The Atacama Large Millimeter Array listens to the cold radio tones of molecular clouds, tracing the chemistry of creation. The Chandra Observatory reads the high-energy signatures of black holes and supernovae. The Ice Cube Neutrino Observatory, buried deep in Antarctic ice, catches ghostly particles that pass through planets as if through air. Gravitational wave detectors, like LIGO and Virgo, feel the universe flex and tremble as massive bodies collide. Together, these machines create a chorus of perception vision that stretches across the entire spectrum of reality. They are the means by which the universe continues its own self-discovery. For every telescope that captures light, there is a detector translating vibration, a spectrograph analyzing motion, a computer interpreting pattern. The cosmos has built a consciousness within itself, a species capable of inventing eyes vast enough to see its own birth. We are the mirror neurons of existence, reflecting back what the universe once only implied. And yet, amid this grandeur, the instruments are fragile. They rely on precision so fine that a speck of dust can disrupt a decade's work. A misalignment by a fraction of a millimeter can blur a billion years of light. Scientists care for them like monks tending sacred fires, adjusting mirrors, cooling sensors to near absolute zero, protecting them from vibration, time, and atmosphere. Each photon that strikes a detector is a triumph of devotion, a handshake across eternity. These tools have changed not only what we know, but how we feel. To see the pillars of creation in sharp relief, to witness the dance of merging galaxies, to watch the shadow of a black hole, these are not cold acts of measurement. They are encounters with awe. The instruments do not diminish wonder, they deepen it. They reveal that precision and reverence are not opposites but partners. To measure something truly is to love it enough to want to know it completely. And they continue to evolve. New observatories are being planned, ones that will listen for the faint hum of the first gravitational waves, map the chemical breath of exoplanets, and detect biosignatures light years away. Each innovation expands the vocabulary of perception. The more we learn to listen, the more the universe seems eager to speak. It sends us photons, neutrinos, vibrations, and even silence, each a different dialect of truth. In the quiet of control rooms, data flows across screens like constellations reborn. Numbers appear, and behind them, meaning unfolds. The temperature of a star, the age of a galaxy, the faint signal of a world that might harbor oceans. These are not just readings, they are glimpses of intimacy between mind and cosmos. Technology becomes tenderness, circuitry becomes attention. The machines we build are not separate from wonder, they are its continuation in metal and glass. To think of these instruments as mere tools is to underestimate their grace. They are the organs of cosmic memory, translating the infinite into form we can understand. Each telescope is a window through which the universe sees itself more clearly. Each measurement is a heartbeat shared across time. Someday, perhaps, humanity will build observatories beyond the solar system telescopes, orbiting other stars, listening to the whispers of alien skies. Even then, the purpose will remain unchanged, to know the universe by knowing ourselves within it. The instruments will continue their vigil, gathering light, listening for waves, translating silence into understanding. They are, in their quiet way, the purest form of prayer, not supplication, but attention. To point a telescope into the dark is to believe that what is unseen still matters. That meaning exists beyond the horizon. The universe answers in its own time, and when it does, the instruments sing a data stream, a spectral line, a curve on a graph, proof that between matter and mind there is still conversation, still wonder, still light. There comes a point in all great stories where the listener begins to ask not how they continue, but how they end. The universe, too, tells its tale with a beginning, a middle, and perhaps a closing chapter written in light that will one day fade. Cosmology, that patient study of time's long breath, has carried its questions far beyond observation. The same data that revealed expansion, acceleration, and dark energy now invites the most difficult thought of all. What happens when the music stops? Physicists have traced multiple futures for the cosmos, each both terrifying and serene in its inevitability. The first is the slow death of heat, the Big Freeze. In this version, dark energy continues its gentle but relentless work, stretching space faster than gravity can hold it together. Galaxies drift apart, stars exhaust their fuel, and new ones cease to form. The night grows darker, the temperature falls, and energy diffuses into uniform stillness. It is not an ending of fire, but of silence, a final equilibrium where every motion has ceased, every light has gone out. The Big Freeze carries a strange tenderness. It is the universe aging gracefully, declining into rest. Time continues, but with nothing left to measure it. Black holes, those last beacons of structure, eventually evaporate into Hawking radiation, fading into nothing but photons whispering across an endless night. Even those photons, stretched by expansion, lose their warmth. The cosmos becomes an ocean of ghostly radiation, too thin to stir an atom, too cold to remember what life once was. Another possibility lies in the opposite direction, the Big Rip. If dark energy is not constant but grows with time, Its repulsive strength could one day overcome all bonds, even those that hold atoms together. Galaxies would separate first, then solar systems, then planets, and finally matter itself. Molecules, protons, and space-time would be torn apart in a crescendo of expansion. It would be the most absolute unraveling imaginable, not destruction by fire, but by too much freedom. The universe, unbound, would dissolve into nothingness, its very fabric undone. Between these extremes exists a gentler speculation, the big crunch, the idea that gravity might someday halt expansion and pull everything back. Galaxies would fall inward, temperatures would rise, and time would end in a mirror of its beginning, a cosmic inhale answering the ancient exhale. Some imagine this cycle repeating, birth following death, expansion following collapse, each universe giving way to another in endless rhythm. Existence itself becomes breath, oscillating forever between creation and return. Each scenario reveals something more about beauty's strange endurance. Whether the cosmos ends in chill, rapture, or rebirth, its story obeys the same balance that governed its birth. Entropy and order, gravity and release, darkness and light, the dualities persist until the very last. Even endings, it seems, are symmetrical. And yet, perhaps end is the wrong word. The universe may not conclude, it may simply transform beyond our capacity to recognize it. In the deep future, time might stretch so vast that consciousness evolves into new forms, capable of thought without energy, awareness without matter. There could be minds woven from geometry itself, existing as patterns in space-time long after stars have died. What we call death might only be metamorphosis, the cosmos continuing its conversation in a language we no longer speak. Already, faint traces of that destiny touch the present. The night sky, though full, is receding. Every galaxy we see today will one day drift beyond visibility. The horizon of the observable universe is not fixed. It moves outward faster than our light can follow. Each star we admire tonight is a goodbye delayed by distance. The universe is already becoming memory. But memory is its own kind of immortality. The light that leaves a star never truly vanishes. It simply spreads thinner, woven into the fabric of time. The photons that reach your eyes have traveled through cosmic history, carrying the record of events long finished yet still unfolding in their glow. The universe does not erase, it archives. Even in its final fade, every moment remains somewhere in the infinite stretch of space-time, recorded in curvature and vibration. There is a quiet grace in these possible endings. The Big Freeze is a lullaby, the universe falling asleep after its long labor. The Big Rip is a wild liberation, matter freed from all constraint. The Big Crunch is renewal, a return to simplicity. None of them diminish the beauty of what has been. Each, in its way, fulfills it. For the universe was never meant to be permanent. Its impermanence is the reason it can change, evolve, and give rise to wonder. If consciousness endures anywhere within that future, perhaps it will not mourn the dark. It will recognize that even in final stillness, the laws that shaped galaxies and hearts remain quiet, balanced, infinite. In that realization lies peace. The universe will end as it began, not with noise, but with symmetry. And for a long, immeasurable moment before the last photon fades, it will be perfectly, unbearably beautiful. In the hush that follows understanding, a realization begins to unfold that beauty and truth have never been separate, only seen from different sides of the same light. The universe, vast beyond imagination, does not require meaning to be magnificent. And yet, meaning arises anyway, as naturally as dawn. Somewhere between the equations and the stars, between gravity and thought, between silence and song, existence reveals a tenderness beyond necessity. From the beginning, the cosmos has spoken in two voices, one of order, one of awe. The laws of physics are the grammar, wonder is the tone. Together they compose a story that does not end in comprehension, but in intimacy. Every discovery, symmetry, quantum strangeness, expansion, collapse has led not to closure, but to a deeper sense of belonging. The more the universe explains itself, the more it invites reflection. Knowledge, rather than dissolving mystery, refines it into clarity. And perhaps that is the most beautiful fact of all, that the universe allows itself to be known, that it makes sense, however partially, to a fragile species on a small blue world. Out of chaos came coherence. Out of fire came eyes capable of seeing it. This is not an accident of probability, or if it is an accident so exquisite that it feels like intention. The cosmos, indifferent in mechanism, is generous in outcome. It gave rise to beings who could notice its generosity. When one looks at the night sky now, it is impossible not to feel both the weight and the gentleness of that gift. The stars are not distant strangers. They are our ancestors, their light our inheritance. The atoms within us once burned, drifted, collided, and cooled. Their journeys were long, but not aimless. They moved toward complexity, toward self-recognition, toward us. In that sense, consciousness is not a fluke. It is the universe continuing its experiment in awareness. We are, in every measurable way, local phenomena arrangements of carbon and time, matter borrowed and briefly animated. Yet in another sense, we are as large as everything, for we contain memory, the echo of the Big Bang, the rhythm of stellar death and rebirth, the trace of light that has travelled since before there were eyes to receive it. When we think, when we love, when we dream, we extend the story that began with expansion. Thought is the next chapter of creation. The tenderness of existence lies in its paradox. It is ruthless in process, yet gentle in result. Stars die so that life may live. Entropy rises so that structure can form. Even darkness, feared as emptiness, is the necessary background against which light can be seen. The universe is not moral, yet it behaves with a kind of grace, a balance that allows fragility to persist inside immensity. Out of indifference emerges beauty, out of inevitability, peace. Science, in its deepest form, is not conquest but communion. To study the cosmos is to participate in its unfolding, to add awareness to its silence. The equations, the data, the maps of galaxies, these are the universe observing itself through the mirror of human understanding. When we point a telescope outward, we are not looking into something foreign. We are looking back into our origin, our material, our truth. The stars do not look down, they look across. And so the journey of comprehension becomes an act of affection. The more precisely we measure, the more intimately we belong. Every constant, every symmetry, every uncertainty reminds us that we are woven into the same fabric we seek to describe. There is no outside to the universe. To exist is to participate. The final lesson, whispered by time, is that beauty is not the decoration of truth, it is its shadow. Where truth walks, beauty follows, silent and exact. To feel awe is not to be deceived. It is to recognize alignment, to sense that our perception has briefly matched the rhythm of reality. The music of the spheres never stopped playing. We have simply learned to hear it again, in frequencies of reason and love. When the mind quiets and the night expands, the cosmos ceases to be distant. The boundary between observer and observed softens. The heart beats, and somewhere a pulsar echoes it. Light travels, and neurons fire in sympathy. We are not in the universe, we are the universe, momentarily aware of itself. That awareness, fragile, transient, luminous, may be the closest thing to eternity we will ever know. So let the facts be beautiful, let them soothe, let them remind those who listen that existence, for all its vastness, is not cold. It is precise, patient, and full of grace. The galaxies will continue to spin long after our eyes close, and yet their meaning will remain, because meaning is the act of seeing. In seeing, we complete the circle. The cosmos creates the mind, and the mind, in turn, gives the cosmos reflection. The stars do not need our wonder, yet they shine as if waiting for it. Perhaps that is the true symmetry not between matter and energy, but between knowing and being known. To gaze upward is to take part in that symmetry. To fall asleep beneath that endless canopy is to trust it. The universe hums softly in return, a lullaby in light and law, saying, "You belong to this. You always have."